Hi, it's Miss O'Connor here, and I'm here to talk to you again about rates and ratios, Chapter 4, and today we're going to talk about ratio tables. Now, you might be asking yourself, well, what is a ratio table? Well, a ratio table is a table such as this, in which the columns are filled with pairs of numbers that have the same ratio. So we've applied our knowledge of rates and ratios into using ratio tables. Here's a little example for you. Now suppose that we are making orange juice from frozen concentrate. And in order to make this orange juice out of frozen concentrate, we are going to need 3 cans of cold water. So that means for every can of frozen orange concentrate, we're going to need 3 cans of cold water. So here in our table, we have 1 can of frozen concentrate, and for that, we're going to need 3 cans of cold water. Well, say we're inviting some friends over, and so we are making, obviously, more orange juice out of frozen concentrate. Well, we're going to go ahead and make 2 containers of frozen concentrate. Therefore, we're going to need more water. We needed 3 cans of cold water for 1 can of cold concentrate, but for 2 cans of concentrate, we're going to need 6 cans of cold water. And then if we decide to invite even more people over and we make even more orange juice, we're going to use 3 cans of concentrate, but then for 3 cans of concentrate, we will need 9 cans of cold water. So this is just a little example of how ratio tables are actually used. Let's take another look. You all have heard of my little dog Moose. He eats a lot of food for a Dachshund. So my dog Moose eats 1 cup of dog food every 8 hours. At that rate, how many cups of dog food would he eat in 24 hours? Well, here we have our dog food here, and this is cups. And so he ate 1 cup of dog food in 8 hours. But we're trying to find out how much dog food then, how many cups of dog food would he eat in 24 hours? Well, what you would do is you would look at the relationship between 8 and 24. And I know that 8 times 3 is 24. So you multiply 8 times 3 times 24. And whatever you do on the bottom here, you need to do on the top. So 1 times 3 equals 3. And that's the number that we're looking for. So in other words, the ratio table has been completed. My dog will eat 3 cups of dry dog food in 24 hours. Now, let's talk about Sebastian's allowance. Sebastian receives $8 every week for allowance. Now, we want to know then, how much does he earn after 4 weeks? Maybe he's trying to save up for something special, and he would like to know approximately how much money he would have to see if he could buy whatever he wants to get. So he gets $8 for allowance in 1 week. Now in 2 weeks, he would get double that. So 8 plus 8 is 16. So he would get double that. Now in 3 weeks, okay, this is 8 times 2 is 16, or 8 plus 8 is 16. In 3 weeks, you had 8 plus 8 plus 8, which would be 24. Or 8 times 3 is 24. And then on the 4th week, it would be 8 plus 8 plus 8 plus 8, or 8 times 4 is $32. So in Sebastian's 4th week, he would have accumulated $32 for his allowance. Now, we've been doing some ratio tables that involved equivalent ratios of larger quantities, but you can also go the opposite way. to where you have equivalent ratios of smaller quantities. That means that we had a smaller number and we were working towards a greater number before. Now we take a greater number and we're working towards a smaller number. So it's the opposite. We call this equivalent ratios of smaller quantities when going from a larger to a smaller number. Now, in this problem, Luke loves to participate in hot dog eating contests. So we are going to pretend that Luke ate 66 hot dogs in 12 minutes. That's a lot of hot dogs. Now, if he ate at a constant rate, that means at the same speed and the same pace, how many hot dogs did he eat in 2 minutes? Okay, well, he ate 66 hot dogs then in 12 minutes. That's the information that we know. Now, we want to find out how much he ate in 2 minutes. Well, if we divide 66 divided by 2, we can half that number, and half of 66 is 33. If we have 12 and we divide 12 by 2, we get 6. So that means that we know that he ate 33 hot dogs in 6 minutes. But we had to find out here with 2. So now we're looking at the relationship between 6 and 2. Well, I know 6 divided by 3 equals 2. And 33 divided by 3 equals 11, which gives us our answer that he can eat 11 hot dogs in 2 minutes. Let's try another one. Ben runs 8 kilometers. Sorry for the wiping off of my boards when I slide them. I'll have to brainstorm something to do with that. Ben runs 8 kilometers in 60 minutes. So here we have this depicted on our ratio table. So he has the distance up here of 8 kilometers and the time is 60 minutes. And so this is time in minutes. Now, at this rate, how long would it take him to run 2 kilometers? So we're trying to figure out now how to get to this 2. Well, if you go ahead and have this, 8 divided by 2 equals 4. So 8 divided by 2 equals 4. And 60 divided by 2 equals 30. Okay, so we basically just cut this in half. So he can run 4 kilometers in 30 minutes. That we know. We're trying to figure out here how long it takes him to run 2 kilometers. So you're looking at the relationship between 4 and 2. Well, I know that 4 divided by 2 is equal to 2. And of course you have to do the same thing on top, on bottom. So 30 divided by 2 is equal to 15. And the answer is 15 minutes. So how long would it take him at this rate to run 2 kilometers? The answer would be 15 minutes. Now, one more thing about ratio tables. Sometimes you have to use something called scaling. This is an example of scaling, and we'll be practicing this more in class later this week. Now, scaling sometimes involves multiplying and dividing. So pretend like we are buying some cans of corn, and we find out that they're on sale at 10 cans for $4. So here we have our ratio table, and I've put in 10 cans, and it costs me $4 for that. But I have to find the cost of 15 cans. Maybe I'm making some recipe that's going to have a lot of corn. All right, so in order for us to figure this out, we're trying to get to finding out this question mark here of how much it's going to cost for 15 cans of corn. So we know that 10 cans cost $4. Now we can divide by 2 here, and of course whatever we do on top, we have to do on bottom. So 10 divided by 2 equals 5. And 4 divided by 2 equals 2. Now I need to look at the relationship between 5 and 15. Well, I know that 5 times 3 is 15, and I can say 2 times 3 is 6. So we would need $6 to buy 15 cans of corn. Thank you for watching today, and the secret password is corn. See you tomorrow.